Hello everyone. Our today's module is in continuation with the previous module. In the previous module, we started a discussion with cellular system. In cellular technology, the whole geographical area is divided into small units, each unit known as the cell. The motivation behind the development of this technology was to replace a single high power transmitter receiver antenna with a number of small low power transmitter antennas strategically placed over the geographical distance. Now the reason was that when I'll having a low power transmitter antenna, then it will reach only up to a particular limit, after which the frequency allocated to that particular transmitter can be reused, hence increasing the capacity and increasing the number of channels available. We also saw that the neighboring cells are allocated distinct frequencies, that is non-overlapping frequencies, but that group of cells which non-overlapping frequencies can be repeated, that group of cells is known as cluster. So by repeating the cluster in a systematic way, I can assign same frequency to two different cells in such a way that they are sufficient distance from each other. These cells are known as co-channels. We also saw that if a cluster is smaller in size, then the number of then the capacity would be increased, but the handovers would be frequent, more infrastructure would be required, and so on. But if the cluster is bigger in size, then more number of distinct channels would be required, at the same time capacity would be reduced. So in this module, we will be continuing our discussion with the cluster. We will see that what is the distance between the co-channel cells, more the distance, less the interference. So we will see some mathematical notations of the distance between the co-channel cell by deriving the distance between the adjacent cells which are having non-overlapping frequencies. We will find the area of a particular cell. We will see that how a cluster increases the capacity by looking at a mathematical illustration. Then we will be looking at the different channel allocation schemes, that is how the frequency channels are allocated to the cells. So there are two techniques, fixed and dynamic. In fixed allocation scheme, the cells are allocated on a fixed basis, that is the number of cells are allocated, number of channels are allocated to cells, and if a user wants to communicate and a channel is not available, it won't be given. In a channel allocation scheme, there is a central pool where all the channels are kept, and when a user wants to make a call, a channel is being allocated to it on dynamic basis, and when the call is complete, the channel is returned back to the central pool. We will also see that what are handovers and handoffs, and what is the implication of mobility on the quality of the voice, and how handovers are used to maintain a seamless connectivity so that a call or a data service is not dropped. So we will start with the derivation of the distance between the co-channel cells. How do I calculate the distance between the co-channel cells? For that derivation, let us look at the following terms. These terms we have discussed in the previous module also, but for the recap, the size of the cluster can be 3, 4, 7, 9, 12, 21 and so on. We said that there is a predefined way in which this size of the cluster has been calculated. The size of the cluster is according to the two integer values which are known as shift parameters I and j. Now what is this I and j? I and j are the steps by which I can go from one co-channel cell to another co-channel cell. For example, let us see that if I want to go from one co-channel cell, which is described by frequency A, you can refer to the diagram, to the nearest co-channel cell, again represented by a frequency A. Then what do? I take I step along one direction and j step along another direction. Now what will be this value of I and j? This value of I and j will be determined from what is the size of the cluster, or in other words, the size of the cluster can be calculated according to as the shift parameters I and j. So for the cluster sizes, the value of I and j are C is equal to 1, I is equal to 1, j is equal to 0. For C equal to 3, it's I equal to 1, j equal to 1. For C equal to 4, it's I equal to 2, j equal to 0. For C equal to 7, it's I equal to 1, J equal to 2. For C equal to 9, I3, J0, and for C equal to 12, it is I0, J2. So, using this values of I and J, the formula for the cluster size is derived as, cluster size is given by I square plus Ij plus J square. You can just take an exercise that the values given on the screen in the table fit into this formula or not. Now, the distance between two adjacent cells. Okay. Now, why I need to find this, we will just see shortly. The distance between two adjacent cells where r is the radius of the cell is given by 2r cos pi by 6. Now, this formula has been derived from the geometry of hexagon. You just take the centers of two cells and to find the distance between these two. Now, to go from center to the extreme point, you will be needing the radius. Again, from the extreme point to the center of the second cell, you will be needing the radius. So, this 2r distance is there, plus to find the d, you take the angle of it, which is cos pi by 6. So, hence 2r cos pi by 6 is root 3 by 2. So, the distance between the two adjacent cells comes out to be root 3 multiplied by r. Now, how do I find the distance between the two co-channel cells? That is, the distance between the adjacent cells is given by root 3r. If I multiply this term by the cluster size, obviously I get the distance because this cluster has been repeated. Okay. So, d is equal to root 3c r. Okay. So, the distance between the co-channel cells is given by the term root 3 c and r. The factor q is known as co-channel reuse ratio. Now, what is this co-channel reuse ratio? The distance between the co-channel cells divided by radius of each cell is known as co-channel reuse ratio. So, putting the values of d and r, what is d? We just evaluated, it is root 3 c r divided by r. So, which is equal to under root 3 c because r cancels out. So, co-channel reuse ratio is given by root 3 c. Now, obviously, smaller the value of q provides large capacity. Cluster size is small, whereas large cluster values of q increases transmission quality due to smaller levels of co-channel interference. Let us look at the values of q for different cluster sizes. For cluster size 3, q is given by 3, that is root 3 multiplied by, then for a cluster size 4, it is given as 3.46. For cluster size 7, it is given by 4.58. It is just an exercise for you that put it in the formula above and then calculate the values of q which has been given in this table. For cluster size 9, the value is 5.2. So, you can see that as the size of the cluster is increasing, the reuse ratio is also been increasing. That is, more and more cells can be reused, hence increasing more and more capacity. Right. But small cluster sizes also pose a problem. This is that the interference would be more because the cells with same frequency are coming closer. Small cluster size means small the co-channel distance and hence more they will be closer, more interference would be there. But the capacity would be increased because we said that the purpose of repetition of cluster is to increasing the capacity by replicating the frequencies reused. Now, larger cluster size, it demands for more number of unique channels, but also offer a high transmission quality. Now, there is also the other way around by which I can increase the transmission quality without necessitating an increase in cluster size. That is, cluster size would be same, but still I can reduce the interference as well as increase the capacity. What is this technique? This technique is known as sectoring. Sectoring means, what is a sector? Sector is a part of the circle, and generally like 120 degree circle completes 360 degrees. So a sector forms 1/3 of that, which can be 120 degree. Now, but what is special in this technique is that the base station is not located at the center of the cell, because the center of the cell will indicate that it is a omnidirectional antenna and it will spread the transmission in all the directions. But the sectorized or the sectors are formed when the transmission of the antenna is only in a particular direction. That is, for a particular sector, the antenna will only cater that area which is represented by that particular sector, which is not, of course, a circular geometry. Hence, the antennas used in sectoring are not omnidirectional, they are directional in nature. Okay. So, a omnidirectional antenna should be replaced by directional antennas, and they are not in the center, they are on the periphery of the cell. Hence, by using this arrangement, different sectors have been found. You can see in the diagram that a cell is been split into 3 120 degree sectors. Now, the base station feeds 3 120 degree directional antennas, each of which radiates into one of these sectors. Again, this diagram represents the formation of the sector. It is a 3-dimensional view. So, 1, 2, 3 sectors are there. Now, the channel sets which have been allocated to the cell also has to be divided among the sectors. So, if there are 9 channels which are allocated to the cell, each sector will be assigned 3 channels. So, each sector is assigned 1/3 of the available cells of channels. Again, what is the problem here? I have been able to reduce the co-channel interference. I have been able to maintain the capacity, but a cell is of course, a sector is of course a part of the cell. Okay. So, when a user moves from one sector to another sector, again the frequency channels allocated to these sectors are different. So, what will happen is that a handoff would be required. So, within a cell only 3 times the handoff would be required. So, increasing the number of handoff when the sectoring is employed, it puts an overhead on the switching and control link elements of the mobile system. So, there is a solution to this problem also. The concept is known as micro cell zone. Now, when do we require handoffs? When the number of channels allocated are different in different areas. Now, micro cell zone comes with a concept opposite to it. It says that the cell is divided into 3 microcell zones, with each of 3 zones connected to the base station and sharing the same radio equipment. But the thing is that all the microcell zones within a cell use the same frequency used by that cell. Now, the problem is being solved. Since the same frequency is used within that particular cell, and if the device moves from one microcell zone to another microcell zone, no handover would be required. So, the base station simply switches the channel to a different zone site and no physical reallotment of channel would take place. Hence, no handovers would be required. So, we have seen that how a cluster can be used for frequency UU, what is the distance between the co-channel cells, and how the capacity can be increased by using clusters of different sizes. Just look at an illustration. Now, suppose a system has got S duplex channels and each cell has been allocated K channels. So, each cluster has how many cells? C cells. Okay. So, the number of channels are S, each cell has K channel and the size of each cluster is C. Therefore, obviously, to handle all these things, S equal to Kc. That means the available channels had to be used between these cells and these clusters only. Okay. So, we will find that how the capacity is changed. Now, if this cluster is replicated m times, so the capacity will be increased m times. So, capacity is given by ms. Number of channels were only S, but the number of replications of that cluster has increased the capacity by m-fold. So, if the number of channels and cluster sizes are fixed, capacity is directly proportional to number of times cluster is repeated in a fixed area or total number of users which can communicate without interference is directly proportional to the number of times the cluster is being repeated. Let us look at an example. Suppose the geographical area is 1569 kilometer square. So, each cell occupies 7 kilometer square each. So, cluster size is equal to 4. So, area covered by cluster is 7 multiplied by 4, because the area covered by a cell is 7 kilometer square. Cluster size is 4, that means in a particular cluster there are 4 cells. So, the area covered by this cluster will be 7 multiplied by 4, which is equal to 28 kilometer square. So, how many clusters would be required in this area? So, total area is 1569 kilometer square. The area covered by the cluster is 28 kilometer square. Therefore, the number of clusters, if I divide this, I get 56. So, if I increase the cluster size, the number of cluster of course would be reduced, that is 1569 divided by 49, which is equal to 32. Let us move to next topic, it is how channels are allocated between the cells. There are two strategies, fixed channel assignment and dynamic channel assignment. In fixed channel assignment, each cell is allocated a fixed number of voice channels. So, any communication within the cells had to be made using these voice channels only, and if a user wish to communicate and ask for a channel and all the channels are being exhausted, then it will have to wait for another channel to get free, then and only then it will get that particular channel. So, in this case the user wants to place a call, or if it after a handover a channel needs to be allocated to it, the subscriber won't get the service, the call will be blocked. The circuitry required in this type of scheme is simple, but it is the worst channel utilization. Why? Because a user or the device will keep the channel along with it whether it is using or not, and hence no other user will get it. Just a variation to this scheme is borrowed channel allocation scheme, in which when the channels allocated to a particular cell gets exhausted, then a very interesting thing which is done and which we Indians are very good at, that borrow the channels from the neighboring cells. This is known as borrowed channel allocation scheme. The channels are borrowed from adjacent cell if all the designated channels have been occupied. Now, but the care has to be taken to ensure that none of the calls in progress are being interrupted, either of the neighboring cell or of the current cell. The cell which asked for the channel is known as acceptor cell, and the cell which borrow the channel is which provides the channel is known as the donor cell. That is, acceptor cell would be one in which all the nominal channels have been exhausted, and the donor cell is one in which from which the channels are borrowed to accommodate new calls. Now, there are different strategies for borrowing. Okay, because since we said that every neighboring cell has been assigned distinct frequency and the cluster is there. So, surrounding one cell there can be either 2 cells or 3 cells or 6 cells and so on. So, from where the channel should be borrowed? There are 3 techniques. Borrowing can be done from the adjacent cell which has largest number of free channels, that is borrowing from the richest. Okay, no exploitation. Only the one which has got the more, we go and ask from it. The second is a greedy one, in which you don't make the effort to search a particular cell for channels. Whichever comes first, you borrow from it. That is, select the first free channel found for borrowing using a search algorithm. And thirdly, which is known as a basic algorithm with reassignment, in which after borrowing the channel, when it becomes free, it is returned to the donor cell. Now, only the thing is that to be available for borrowing, the channel must not interfere with the existing calls. The next scheme is dynamic channel allocation. In dynamic channel allocation, all the channels are kept in a central pool and are assigned dynamically to new calls as they arrive in the system. And after each call is completed, the channel is returned to the central pool. It is fairly straightforward to select the most appropriate channel for any call based simply on the current allocation and current traffic, and with the aim of minimizing the interference. To avoid co-channel interference, any channel that is used in one cell can only be reassigned simultaneously to another cell if the distance between the two cells is larger than the minimum reuse distance. That is what we are discussing again and again. Now, there are two types of dynamic channel allocation schemes, a centralized DCA and a distributed DCA. In a centralized DCA, as the name itself indicates, that there will be a single controller selecting a channel for each cell. That is, only one entity would be responsible for doing that. Whereas in distributed DCA, there are number of controllers which are scattered across the network, and they are usually the MSCs. The third allocation scheme, which takes the advantage of both FCA and DCA, is the hybrid channel allocation scheme. It is a combination of both. In a hybrid channel allocation scheme, the number of channels available are divided into two sets, fixed set and the dynamic set. That means it has utilized both the scheme. The fixed set consists of the channels that are assigned to the cells as an FCA scheme, right? Whereas a dynamic set is shared by all the users in system to increase the flexibility. Now, what does that mean? There is a dynamic set which is kept and the fixed channel has been allocated to the cells. Now, if the channels with the particular cells get exhausted, now it can take it from the dynamic set. That is both a combination of fixed channel allocation and dynamic channel allocation. So, whenever a call requires service from a cell and all its nominal channels are busy, a channel from the dynamic set is assigned. So, this is about the channel allocation scheme. Now, let us move to a situation again very typical to cellular system, which is known as handovers and handoffs. Now, this terminology varies from place to place. In some continents, the word handover is used, and in some continents, the word handoff is used. What is this term? It says that now we have seen in the cellular system also that since the antennas are low power, so as the user moves away from it, the strength of the signal will diminish. So, the user have to be at the same time, the strength with the neighboring base station increases. So, the caller service have to be moved to the new base station, and this situation is known as handover. Now, the only requirement for handover is that they should be carefully performed so that there is no call drop, and also the performance should not be degraded. What are the parameters which should be known for handoff to occur? The signal strength of the base station with which the communication is made along with the signal strength of the surrounding stations. Now, who does this? There are in different communication standards, different entities are involved in this, but the basic criteria is that a device is having a communication with one particular cell, it is moving away from it and it is getting closer to another cell. Now, hence it will be getting different signal strength from both the cells. Now, if the difference between these signal strength is up to a particular threshold value, then no handoffs would be required, and if it goes below that threshold value, handoffs will be initiated. Now, what is the significance of this threshold value or threshold margin? Because the difference between the signal strength says that now I am getting much better quality from the new base station, so I do not require the channels from the old base station. Hence, the old base station transfers the call or service to the new base station. At the same time, it should also be ensured that there is availability of channels with the new base station. We will be discussing the handovers more in detail, that is how it happens, how the threshold margin is being measured in the handover topic of the GSM network. We will also see by an example that what mechanisms are being followed when a cell is being handed over from one cell to another cell, or from one base station to another base station, or from one BSC area to another BSC area, and so on. For the time being, again there are two types of handovers, hard handover and soft handover. Hard handovers is more commonly used in GSM, and the name itself says that the connection with the existing base station, or the existing connection must be broken before the new one is established. The reason here is that a mobile or a device can only transmit on one frequency at a time. Therefore, the connection must be broken from the older frequency, and then and only then the connection is re-established. This is also known as interfrequency hard handover. And one might wonder that why we do not observe it, because the time for which the old base station releases the channel and the new base station gives the channel to the base station to the device is very small as to be observed. Another category is soft handover. This is used in 3G technologies which uses CDMA. Now in CDMA there is no frequency division, therefore it is possible to have neighboring cells on the same frequency, and this opens the possibility of having a form of handover when it is not necessary to break the connection. So a device can be on two frequencies at the same times. Right? This is also known as make before you break. So once the connection has been established with the new base station, then the connection with the old base station is being released. So these are the two categories of handovers. Just take a quick look at what are the handovers, or what type of handovers are used in different communication standards. For example, in 1G, the handovers were handled by the base station supervised by MSC. So handoffs in this generation are known as network controlled handover. Okay, the base station monitors the signal strength of voice channel to determine the relative position of the subscriber. The MSC monitors the signal strength of the users in the neighboring cells, which appears to be in the need of the handover. So handover is maintained by the network, hence the name network controlled handover. The approximate time required to make a handover was about 5 to 10 seconds, and the power was 6 dB to 12 dB. Now as the technology evolved, in the 2G systems, the MSC was relieved from the entire operation. That is, the handover decisions were taken by the mobile itself, and hence were known as mobile assisting handover, or MAHO. The mobile center measures the power changes received from nearby base stations and notifies the two base stations. Accordingly, the two base stations communicate and the channel transfer takes place. Now here the circuit complexity was of course increased, but the delay in handover was reduced to 1 to 5 millisecond, and the power requirement was of less than 5 dB. Now again, in current 3G systems, the measurements are performed by the mobile station, and automatically the mobile station itself upgrades the channel to the nearer base station, because it cannot, in 3G systems where the communication is so fast, the delay which was offered in the 2G system, that is mobile assisted handover, that was also not affordable. Hence the mobile itself took the control of handover, and hence the name mobile controlled handover. So here the delay is only 100 millisecond, and the value of power required was 20 dBm. This has also improved the quality of service drastically, but of course increasing the complexity of circuitry. So in this module, we discussed the clusters and the cluster sizes, the co-channel distances, the area of the cell, how the cluster sizes determine the co-channel distance, and some mathematical terms related to the clusters. We have also seen the different channel allocation schemes, as in fixed channel allocation scheme where each cell is allocated fixed number of cells, and dynamic channel allocation scheme in which the channels are kept in a central pool and are given to the devices as and when required. We also saw that what are handovers and handoffs and why they are more required in cellular systems. What happens when a handover takes place? The type of handovers, hard handover and soft handover. Hard handover, whereas the connection with the old base station is first broken up and then the new base station is being connected, and that time is hardly noticeable. In soft handover, the connection with both the stations continues, and then after establishing the connection with the new base station, the channel with the old base station is being released, which is used popularly in CDMA. We also saw that in 1G, 2G, 3G what are different types of handover mechanisms are used. This is based on that who is the controller of the handover, whether it is assisted or controlled by the mobile station or whether it is assisted or controlled by the network, because a handover is initiated when the signal strengths from the two base stations vary significantly, and this performance measurement can be done either by the mobile station or by the network. So, these different techniques were used in different telecommunication standards. Like in 1G telecommunication standard, the network measured these performances and initiated the handover, hence the name network assisted handover. Whereas in 2G technologies, mobile assisted handovers were used, whereas in 3G technology, mobile controlled handovers are being used. And we have also seen that the delay between the three types of handovers is least in 3G, and that is what is required actually also. The delay is not affordable when quality of service provided is not to be compromised. So, this is about the cellular systems. We will be continuing more and more topics in the paper of mobile computing in the next modules. Till then, have a good day.